We're going to be talking today about events that are unfolding even as I'm making this video. We're going to be talking about our star, our sun. We're going to be talking about some data that is scientific data that has come to us in the form of a paper. Our physicist has been away due to personal issues, and we are grateful that she is back, and she has sent us a paper that, well, I'm going to read it to you word for word, and so that I'll allow everyone to have a chance to see this for themselves. So we're talking about the sun. This is the recent satellite imagery. We can see that there's a sunspot group building here. We can see one's becoming more defined here as it exits. We're going to talk about as well as what we're seeing on other satellites. As you can see, I'm going to just go ahead and start running this. What our concern is this, and it's being reported on other YouTube channels. I hope it gets reported much more mainstream. I don't think it will be. This is the problem, folks. No one's talking about this in, whether we want to call it alternative media, whether we want to call it whatever, I don't know. This needs to be paid attention. Now, Steve Olson and I did a video a couple days ago, and everyone remembers that it was up here around the 18 mark. Ladies and gentlemen, it has not dissipated. You can look at the scale right down here for yourself, and you can see for yourself the density. And density is heat. This is, well, you can look over here on this one. This is as it passed stereo A, I believe. Look at what's happened. There is a direct line connected to our sun. Now, I want to show you the paper. And so this is a physicist's thoughts on what's happening on this cosmic wave of energy. And let's read it together. It says, I have written in the past about my thoughts on what is happening to our sun. SDO images from October 26, 2016 were to me compelling evidence of a brown dwarf binary system in close proximity to the sun and discharging it. Someone has photographed a binary system from the Earth that I believe is very likely to be the brown dwarf binary system that is affecting our sun. Figure 1 shows an image obtained from, and you can see the website here. It's cosmicartifactsresearch.com. You can see the link for yourself. We'll post it. The Cosmic Artifact Research website contains absolute brilliant photographs of what is currently happening in our solar system. So let's pull this up, folks. Figure 1, image of a binary star system. The large amount of ionized material around the larger star makes this star very likely to be a brown dwarf star, and its smaller companion of comparable brightness is very likely to be a brown dwarf star as well. The reason why a binary system in which one of the stars is a brown dwarf star is likely to be made up of two brown dwarf stars is that since a brown dwarf star has used up all its fuel, its potential is lowered. So any star in its vicinity at a higher potential, i.e. any star that has not yet burned through its fuel, will exchange energy with it in an attempt to equalize the potentials. So the higher potential star will lose energy whilst the brown dwarf will gain it. This will continue until both stars are brown dwarf stars with the same potential. This is also why this brown dwarf binary system is weakening our sun. If these brown dwarf stars do not leave, our sun will eventually burn through its fuel and become a brown dwarf star as well. It is also obvious that with the extra objects in our solar system, our planet is experiencing some disturbances. We know that because the number and severity of earthquakes is increasing. However, the reports of a cosmic wave of energy are, in my opinion, not true. If a cosmic wave of energy is made up of radiation, it would travel at the speed of light. And since no information can travel faster than the speed of light, according to Einstein's theory of special relativity, it is not possible for us to know in advance that it is coming. If the cosmic wave of energy is made up of high energy particles, then it would travel at less than the speed of light. But whatever event that was, the cause of such a particle emission would have given off light a long time ago, and that light would have reached Earth by now, in which case it would have been picked up by many satellites, orbit, or even the astronomers on Earth. But where are the images pertaining to such an event? There are none. And in the absence of such evidence, I would have to discount the existence of any such event ever have happened. Now, the solar wind density has been used as evidence that something energetic is hitting the Earth. I do not discount the fact that objects are affecting the Earth, but the solar wind density is not showing any evidence of that fact. Figure 2 shows the highest solar wind density observed for each 24-hour period from December 17th to December 21st. And we all know, we've seen these. This is what we've been talking about. Okay? Figure 2, higher solar wind density in each 24-hour period between December 17th and December 21st, 2016. So this, everyone can see it again. We've linked those websites. Table 1 below shows the highest solar density observed in each 24-hour period combined with other factors pertaining to solar activity, namely solar flares, sunspots numbers, and the area of the sun covered by coronal holes. The information about solar flares and the sunspots comes from spaceweather.com, and the information about the visible area of the sun covered in coronal holes comes from images supplied by the SDO satellite and viewed at heliosphere.org. Table 1, solar activity from December 17th to December 21st, showing maximum 24-hour solar wind density. Major solar flare occurrence, maximum solar flares, sunspot number, geomagnetic storm, occurrence, and the area of the sun's surface covered in coronal holes. So I'm going to scroll on this one. There we go. All right. We're talking about color, density, solar flares, maximum solar flares, which is dismal. It's virtually nothing. Number of sunspots, geomagnetic storms, and the area of the coronal hole by percentage. Now, let us compare this with what was happening a month ago from the November 1st to November 4th, 2016. Figure 3 shows the solar wind density charts, and the solar activity is shown in Table 2. Figure 4 shows the coronal holes on December 20th and November 1st, 2016. Okay? You see, this is November 1st. Figure 3, the highest solar wind density in each 24-hour period between November 1st and November 4th, 2016. Table 2, solar activity from November 1st to November 4th, showing maximum 24-hour solar density. Again, major solar flare occurrence, maximum solar flares, sunspot numbers, geomagnetic storms, occurrences, and the area of the sun's surface covered by coronal holes. So again, let me get this in full screen for you. All right, we saw the previous data. You can go back and make reference to all of this. 20%. There's the picture. Figure 4, images of the sun as provided by the SDO satellite in the 19.3 nanometers ultraviolet on December 20th on the left and November 1st on the left, 2016, showing the area of the sun covered by coronal holes. Notice that if we compare what happened between December 17th and December 21st as shown in Figure 2 and Table 1, so let's go back to Figure 2, Table 1. There it is right there. Pay attention to the coronal hole. Okay. With what happened between November 1st and November 4th, as shown in Figure 3 and Table 2, it becomes obvious that the solar wind density was greater in the November time interval than in the December time interval, shown in Figures 2 and 3, when a so-called cosmic wave of energy was buffeting the Earth. We can clearly see that the light gray in the main circular chart indicated a solar wind density of 40 particles per centimeter to the third power occurs on November 1st, 2016, while the solar wind density never goes above the very light gray, indicating a solar wind density of no more than 35 particles per centimeter to the third power in the December time interval. The real anomalies here are the size of the coronal holes, which I believe are due to the brown dwarf star draining the sun and the fact that there was a geomagnetic storm on December 21st, while the solar wind density does not show that the Earth was being hit by any significant amount of solar wind, as shown by the arc-shaped chart on the right in the last image in Figure 2. And we'll go back and take a look at that. This could be due to another source of radiation, which is very likely because of the extra stars in the vicinity of our sun. Or it could be due to the Earth's magnetic field weakening, also due to the influence of extra objects in our solar system. Figure 5 shows the solar wind density on October 13th and October 14th, 2010. Notice that the density is much greater than anything we have seen in 2016, as the 24-hour density maximum shows up as dark gray and very dark gray. This indicates a solar wind density of 50 particles per centimeter to the third power and 55 particles per centimeter, which is a huge and nothing like what has happened between December 17th and the 21st of 2016. So here's the figure 5. So this is 2010, October. You have to love Physicists. It's the data. All right, let's continue. Figure 6 shows the solar wind density on October 20th, 2010. Notice that the arc-shaped chart on the right shows that the Earth is experiencing a high-density solar wind. The color in the chart is red or pink, indicating 22 particles per centimeter to the third, or 25 particles per centimeter. This is a higher density than anything the Earth has been hit by between December 17th and the 21st, 2016. Well, this is, I'm doing this slow enough where you can go back and, all the charts. But I'm beginning to think I know where this is going, and I don't think I like this. All right, let's go. Table 3 below shows the solar activity for the whole month of October 2010. The solar wind density in October 2010 is much higher, and so is the number of sunspots, than anything we see in 2016. The thing is, 2010 is a solar minimum year. So, the number of sunspots should be far greater in 2016 than in 2010. But we actually see the opposite has happened. We also see that the size of the coronal holes is small in 2010, and that the area of the sun covered by coronal holes never goes beyond 10%. This is an indication of how the sun has weakened since 2010. This has happened because of the brown dwarf binary system in close proximity to the sun and draining its energy. Well, that's more alarming than any cosmic wave or energy wave. Good God, now we find out that they can't exist in the way that we thought they were. All right, table 3, solar activity for the whole month of October 2010, showing maximum 24-hour solar winds. We've gone through this, so you know the routine here, right? So you can, again, go back and compare. Look at the density. And look at the percentage of the sun that's covered by the coronal holes. Look at the number of sunspots. Go back up here and look at this other data so we can, here we go. Look at this, folks. This is November. This is December. That's an alarming trend. Let's finish this out. So here we go. Again, understand this is October 2010. Look at this, folks. Well, there you go. So, according to a tenured professor, physicist, what the data is trending towards our sun is weakening. It also very well appears that that weakening process is intensifying. And it also by scientific data, and I am not a physicist. This is not coming from outside. We've seen in previous charts, but it's what's happening by the intensity of the sun, as you have seen in the white paper. Conclusion? Well, she pretty much tells you by the data. Something is up. So I'll let you do your own conclusions. And we'll see about what we can do about making this paper available. All right. Be kind.